Hi, everyone. Thanks for being here. Today, we will be discussing PLC's Backdoors in Disguise, which is a research that I conducted a while ago that is focused on various features that exist in Rockwell controllers that can essentially turn them into backdoors. So let's start with the presentation. The premise of the research started with this question that we asked ourselves. What dangers does a PLC that's connected to the internet pose? And usually when you analyze this question, you only think about the flows that involve mass catastrophe and the things that we're all discussing throughout this week. This production flow being disrupted, trade secrets being stolen, IP theft and whatnot, and all sorts of safety hazards that can happen as a result of a cyber attack in this domain. But today, I'm not going to be discussing that, because obviously this is something that's very widespread, and it's been very well known throughout the past years. And I want to give a little different perspective about this. So let's fine-tune the question a bit. So now we change it, and we add the fact that we're not conducting any changes to the execution flow. We're keeping it as is, and we're not going to try and do any funny business with the ladder logic, but rather with a different sort of problems. And before you can, I might have lost your attention at the internet-connected PLCs, but this is very much a very evident issue. In Shodan, which is sort of like a Google for computers, you can see that there are still large numbers of controllers that run Ethernet IP, which is Rockwell's protocol. And funny enough, I did this analysis a few months ago, sorry. And the numbers were actually lower. So it's interesting to see that even though there's a lot of hype going on about ICS security, still you have a significant amount of controllers that are connected to the internet. So it's not something that should be easily dismissed. But I'm not going to focus on that either. We'll see that the capabilities that I'll be talking about have nothing to do with being connected to the internet. So let's take a look at this sample case here. We have a network. We have two networks and an attacker that is accessing from the internet. The attacker is attempting to access the production floor, but the the production floor is not connected to the internet. It only has a link with the control center that's reading data from it. So what we want to do here is create a flow in which the attacker can access various assets in the production floor network. So now we have a more concrete goal. We want to enable unauthorized packet forwarding from the attacker into the production floor. And one of the features that we were being slowly made aware of at the time was the SIP connection path. To explain, this allows you to route SIP commands through various SIP endpoints across various protocols. So if you were to look at the graph here, if I were to ask you how many ways you can access from rack 2 to PLC 5 on the top right, the answer would be 4 ways. We have the 2 direct Ethernet interfaces that connect directly to the controller. And also, we have the ControlNet link. And from rack 1, we have 2 ways of accessing, one from Ethernet and one from the DH+ interface. So this set of capabilities allows a lot of connectivity features. And this is something that I haven't really encountered in with other vendors. And I asked myself, what software component is in charge here. I kind of want to play around with it and see what I can achieve there. And the answer, not too surprisingly, is the message router, which is the SIP class 2. Since this is a very complex mechanism, this gives us, as attackers, a lot of wiggle room and a lot of place to try out all sorts of things, so which is something that we highly appreciate. And it focuses on connectivity, which relates to our goal of unauthorized packet forwarding. So I was like all gung-ho on starting to analyze this, looking at the firmware. But I realized I was missing a very basic piece of knowledge as to what a SIP message really is. And there is the message block, which is the control engineer's way of sending messages. And specifically, you can send SIP messages. And not too surprisingly, as you can see in the window here, these are service code and class are very distinct SIP terminologies. So when I'll be showing you how this looks on the wire, you'll not be too surprised to see that this is just a way of sending a SIP packet. And I'll be showing you a short demo to explain how this works. So as you can see here, I am sending a ping request to .157, and I'm getting responses. And I asked the IT guy to not allow me to access 156 directly, so I'm not getting any responses from it. And now I will query the SIP identity of the 157, and I get a response. And not too surprisingly, nothing from 156. So now I will specify a connection path that will route the identity packet through 157 to 156. And as you can see, there's different details. So this is obviously a different controller. And I'm not only limited to identity commands. I can also take a snapshot, which is like Indegy jargon for code upload. So you can carry out pretty much any SIP command that you want. So how does this look on the wire? Not too surprisingly, it's fairly simple when compared to a similar session that's done directly to, say, 157. We only added this small part of the IP address of 156, and all the rest was done automatically by the controllers. So how can we utilize this for our attacking purposes? So we can, so going back to the network scheme, we can get from the attacker's position to the production floor using this once the mediating controller exists there. And so that allows us the connectivity into the production floor, which we were trying to achieve earlier. We can port scan for Ethernet IP devices, just like we send identity packets. If we would have not received any response, obviously this means that there's nothing there, so we can scan for Ethernet IP devices that way. We can carry out any SIP commands that we want, like I showed you in the demo. And this isn't limited only to IP. There are also various protocols in Rockwell's protocol stacks that are used and can be integrated with this capability. And we didn't download any code to the controller, so we had minimal impact to what's the code that's running there. OK, this is all good and well, but what about non-Ethernet IP devices? This is like a limitation that we didn't really have in place when we wanted to forward packets from the networks. And when I was going through the previous the screen with the messages, what I saw that you can send in this screen, you can also create sockets and do all sorts of reading and writing operations directly from SIP, which is quite interesting. And those of you who are familiar with the sockets, it's a very well-known interface. And because this is a SIP command, as all other SIP commands, there's no authentication required. And because it's a socket, it's very robust, so you can send traffic to pretty much any port you want, both TCP and in UDP. So now we'll go to a second demo. Here we're pinging 157 again, but here I would like to show you that with the TTL 63, and we're not in the same subnet. Stop here, please. And now let's take a look at the command. So just like the previous demo, we have a connection path to 156, so we're routing packets via 157, and we're directing these packets to the subnet broadcast command address. And we're clearing the existing sockets, which is not really relevant, but while I'm explaining, will you mind playing, please? Can you please resume the play? And we get responses from various Ethernet IP nodes in the network, as you can see, which wouldn't have been possible using just the existing SIP infrastructure. So how does this look on the wire? We have a class of 342 hexa, which represents a socket object. And the main methods are 4E and 4D. 4E is a write request where we transmit the Ethernet IP discovery packet, and 4D is one where we try and read the responses that came from the various devices. And here's an example of a response. So if you were to analyze this packet, you'd see that this is a valid Ethernet IP discovery response. So now let's discuss the other possible offensive applications. Like the previous one, you can port scan, but you're not limited to any specific port. You can do this device discovery like I just demoed. And you can also, once you have a socket capability, you can also query and analyze what's running in the network, and as a result, exploit known vulnerabilities in case you find anything that's exploitable. And you can also exfiltrate data using these commands. I think that Rockwell identified that this might be like a problematic point. However, if you'll notice, there are some. It's good that they have like a log of these sort of actions that can be taken place. However, as you can see, it's all shut off by default. It's all false here. So, that's not really a good security practice. And also, finding this log screen is not an easy feat. You have to dig I think it's like the most amount of clicks possible in the network interface, in the web interface, and someone has to manually go over this, and even if the log exists, so it's not reported to any SIEM or something like that. And also, you notice that there's no links on the log on each row here. So you'd have to send manually crafted SIP packets in order to enable the log. And nothing's preventing an unauthenticated attacker from just disabling this, doing the socket commands, and just re-enabling it again. So how would a proper mitigation look like? First of all, authentication is probably solves a lot of the problems here. A route whitelist for a connection path, that means that you can only forward packets to known and whitelisted addresses. It's not a free-for-all. You can't just send packets to any address that you can write down in the connection path. And these were like more vendor-specific mitigations, but this is more on the security managers and the networks. So make sure you have good visibility in your network, and know what sort of traffic is regular and what sort of traffic is not regular in your network, and respond accordingly. And going back to the vendors again, it shouldn't be difficult for a user to have a good security policy. Having like some sort of esoteric screen in the middle of who knows where in the web interface is just not going to cut it. So let's sum up. Just by having a controller, specifically a SIP controller, there's an inherent danger that is not limited to the manufacturing process. This is often when you're dealing with dangers of possibly like a nuclear meltdown or something like that. It's easy to ignore the fact that you can route traffic, and which seems kind of trivial when, once everything blows up. So, but it's still something that needs to be taken into consideration. You need to be familiar with the esoteric features of the controllers in your network. Just because these are where the attacker, the places that the attacker is looking when he's trying to break into your network. And proper network hygiene and configuration can be lifesavers in these sort of situations. If you know what's going on and you're able to react to irregular activities. And going back to the network, we had a firewall. If that firewall is configured properly, we can save IT assets from being at risk from the OT assets. So a little bit about me. My name is Roee. I live in Tel Aviv. I've been with Indegy and the military, so I have some security-related background, and the past 4 years been working on the ICS domain. And a bit of a shameless self-promotion. Indegy is a company that exists for the past more or less 4 years. Our main focus is a hybrid solution of both active and passive technology. That is the only way where we believe that you can see the entire picture. And we have, I think, what makes Indegy a unique place to work is having also not only just the IT security aspect of it, but also the OT aspect. So if you're just like only have IT training, you don't know how to access, for example, RS Logics or any other engineering software. You don't know where to look for things like opening sockets, which would raise a red flag for any IT professional. And the other way around is also true. I mean, we have a control engineer that works at Indegy, and I'm sure that if he'd see a create socket, send socket, it wouldn't tell him anything because it just doesn't have that training. So for me, that makes it a very good approach to solving OT, the many problems that exist in the ICS domain. So thank you, guys. I'll be taking questions.
Hello, I'm Jim Betzel, and Chief Network Architect, South Florida Water Management District. And if any of you guys have PLCs, I know you're going to have questions because I know I do. So I'm going to open up the floor. When I hand you the mic, please state your name and the company you work for. And who's going to be first? Because I know there's a bunch. One? Really? Does nobody have these Rockwell PLCs anywhere? You must. I know they sold more than 5 last year. Here you go.
Good morning. My name is Joel Ortiz. I'm with the South Florida Water Management District. I'm in the OT side of the picture. Mm-hmm. Just a quick question. Which Rockwell product were you using for this demonstration?
this, as far as I know, from the Rockwell specs, I think any SIP supporting controller allows the complex path. And as for the socket interface, if you look for like SIP socket documentation, you can see a full list of the controllers that have this feature, or at least at the time that the document was written. It's quite old. But we're talking about control logics, compact logics, pretty much any recent controller in the Rockwell arsenal.
Next. Good.
Hey, Roee, Sam Wilson from Honeywell. Nice job.
Thank
good
you.
work. So without getting too specific, I'm curious if you've found similar exploit techniques in other vendors' PLCs.
We haven't examined that yet, but as far as I know, the connectivity features in Rockwell controllers are a little bit more advanced than what I've seen in other vendors. So, you know, I don't know for sure.
Yeah, Mike Hoffman of Shell. Wondering if you tried some different protocols other than just ping and those kind of things to pass through and route through the PLC.
I'm not sure what you mean.
So for instance, I mean, if you had could you use this path for a RDP, for instance, those kind of things. I mean, because you do see in the ISIS environments a lot where a PLC is actually where you saw multi-homed. And you can almost separate different environments or different
well,
of computers.
you have like an open interface to write data into the network. What sort of data you write into the network, it doesn't really matter. I mean, it can be an RDP packet, it can be Ethernet IP packet. The choice is up to you. It just gives you an interface to do that. Does that answer your question?
More? Come on. I have one. We have a similar situation. This is 2 for South Florida Water Management District, by the way, if anyone's keeping track. We have a similar situation, but we did it inside. We don't expose it to the internet. But we also put it on those interfaces on 2 different networks.
You mind speaking a little bit closer to me?
Sorry. So we have the interfaces on 2 different networks, right? I noticed in your example, they were both on the same subnet.
Mm-hmm.
So you were basically broadcasting out. It was just a switch network, I assume.
Yeah.
Did you try it where you might have one interface on one routed interface, and does it go across that routed interface? I know your broadcast obviously is not, but was there an exploit tried that actually routed through from the inside to
I
the
did
outside?
it like also with ControlNet. So I didn't check specifically for different subnets because that's just not how our lab's arranged. But I'm assuming if it's possible with ControlNet, which is totally totally different, then it should be working fine with different subnets.
And your discussions with Rockwell, were they interested in your findings and putting things in their product to maybe help us do some of your suggestions?
As far as I know, we haven't received any response from Rockwell, but these are features. I mean, it's doing what it's supposed to do. It's just being used in a malicious way. So I don't really know how they can, without addressing like the fundamental security issues in SIP, I don't really see how they can, what they can do about this.